Hi, everybody, and welcome to Organic Chem Analogies. My name is Maria Thomas, and today we'll be talking about what to do when you're given an acidic, basic, or neutral environment. And we'll be talking using the example of carboxylic acid derivatives, which is the same as pi electrophiles with leaving groups. But this analogy will be applicable to pretty much any situation that has these kinds of environments. So for the purpose of this analogy, we'll be looking at carboxylic acid derivatives as electrophiles. So something such as a nucleophile is trying to attack your carbonyl carbon, and the goal of this mechanism is to replace your X group with the nucleophile and create something like this. And your X group is the leaving group. Now, depending on which environment you're in, acidic, basic, or neutral, even though you're trying to achieve the same result, the mechanism you use to get there will be different. So let's start with acidic environments. When you're in an acidic environment, you're surrounded by protons, or positive charges. The way I like to think about it is that you're surrounded by people with positive attitudes, like these guys. They're so happy and so jolly that when you get in there, it's very hard for you to be negative. Their positivity rubs off on you, and no atom or person going into such a positive environment can maintain a negative charge. So let's say this is you going into this positive acidic environment. You can either be neutral and not do anything, or you can choose to maintain a positive charge yourself. But there's just no way that you can be negative around these guys, because they're just so happy and positive. So let's look at a mechanism for this. Your nucleophile is trying to attack the area of low electron density, such as your carbonyl carbon, but can it directly attack? Well, let's see what happens if it does. So it attacks there, pushes those electrons up, and that forms a negative charge on the oxygen, which is not allowed in an acidic environment like we talked about. So instead, you can have the oxygen grab a proton first, forming this, and then you can have the nucleophile attack the carbonyl carbon, which gives you this product. And now you can do things like deprotonate the nucleophile to form the proper tetrahedral intermediate. But now your goal, like we talked about in the beginning, is to remove this leaving group. And you can do that by collapsing the tetrahedral intermediate. But can you do so directly? Let's take a look at what happens. So I'm going to push this to a side so we have some room to work on. So now, if we make the oxygen push down its electrons and kick out this leaving group, let's see what we get. Well, this part looks fine, but this part, the leaving group, left with a negative charge, and that's not allowed in an acidic environment. So instead, we can have the leaving group grab another proton, producing this, and then have the oxygen collapse and kick the leaving group out. And now you can see that the leaving group has left with a neutral charge, which is fine in an acidic environment. And finally, you can deprotonate your oxygen to give the final product. And now if you look back at the mechanism and take a look at everything, you'll notice that not at a single point have you ever formed a negative charge. You formed either positive charges or a bunch of neutral molecules, all of which is allowed in an acidic environment. But I do want to mention one exception to this rule, and that is chlorine. This is actually one example of a leaving group, such as an X group, that can actually leave with a negative charge even in an acidic environment. And that's because it's so large that it can actually stabilize this negative charge. But after leaving, it will go and attack a hydrogen to form HCl. Now let's look at the exact opposite situation. A basic environment. That's when you have a lot of negative charges floating around. Now a negative charge is like a negative person. Angry, jealous, spiteful, and just so unfriendly that when you're around them, it's hard for you to be positive. So instead, when you are in such an environment, you or another atom like you, the only choice you have is either to be neutral or to be negative yourself. In other words, negative charges are easy to maintain in a basic environment, but you'll never see a positive charge forming here. So let's look at the same example for a basic environment. This time, because negative charges are allowed, your nucleophile can directly go and attack the carbonyl carbon, forming your O-, which, as we talked about, a negative charge is perfectly fine and allowed in a basic environment, and your tetrahedral intermediate can go ahead and collapse and directly kick out your leaving group with a negative charge. And because your environment is so full of negativity, that's perfectly fine and allowed. And now finally, let's move to neutral environments. Now, a neutral environment could just have a bunch of neutral molecules, like these guys, or some positive and some negative people. But the point is, no one really cares what you are. So when you're an atom in here, you could be neutral yourself, you could be positive, or you could be negative. And it wouldn't really matter. So let's look at the exact same mechanism in a neutral environment. Now, you could form some negative charges, some positive charges, and the point is that the neutral environment doesn't really care. Now you can deprotonate the nucleophile to give you this, and finally you can just collapse the tetrahedral intermediate and kick out the leaving group without having to protonate it to form the exact same product. And the point is that the leaving group here can leave with a negative charge because the environment honestly does not care. So here's a quick recap of what we talked today. In an acidic environment, everybody's really positive. You're surrounded with positive atoms and charges that the only thing you can do is either be positive or neutral yourself. But you can definitely not be negative around these happy guys. But in a basic environment, everybody around you is really negative. So it's almost impossible for you to be positive, but you can be neutral or negative around them. And finally, in a neutral environment, nobody really cares where you are, so you can get away with being positive, negative, or neutral. I hope this analogy was helpful for you. Thank you for watching.